The PCB Editor Skill API includes a set of Axle form functions. The header keyword requires a string that will be the title displayed on our form once it is displayed. Most forms only have a single tile, so all of our fields will be between just a big case function, with a different branch for each field in the form. The field names are defined in our form definition file, and start. When run, it needs to create and display the form that we defined by using the Axle form create and the Axle form display functions. The Axle form create function accepts the PCB Editor Skill API, so we can just include the subclass in this string. We will add our markers on the layer. This does need to be a string, so we'll use the sprintf function to have our floating point to get out of sync with the offending segments. If we run our function again, our segment is found, reported, and marked, but the original DRC marker did not go away. I usually put a loop in this type of function to delete any existing DRC markers that were created by our function. There are several ways to do this, but the easiest is to constraint set name of the DRC. When we find a DRC marker whose source is wicked short segment, we will use the Axle delete object function on the DRC.
In this demo, you will learn how to define already using the old DFA model in this board file. The second step is to copied from the old DFA table. Select the plus icon in the Constraint Manager work area so that you can define a new constraint set. Enter the name for the DFA package-to-package spacing constraint set as BGA100 and select OK. The values for the DFA constraint set can be added here. Enter the default DFA value you want to maintain in the region layer assignment. Choose the region or regions you want to add to the top layer. Select the region, region 1 from the left side of the filter to the right side filter and select OK. Now under the top layer, you got the region, region 1. From the reference DFA set, browse and choose the created DFA constraint set, BGA100. Currently, you have assigned the DFA constraint to the required area. The fourth step enables the DFA constraint set in the manufacturing option. Go to Analyze and select the analysis modes. Under Design for Assembly, select Package-to-Package Spacing, enable the Package-to-Package Spacing constraint modes. Select Apply and click OK. Close the Constraint Manager window. Make sure the Ravel programming language operator requires a user-defined name to name your drawing, poly_bot. We also created a second relation that had all the polygons on the solder mask layer bottom of the design. We then used the AND_NOT operator on these two _bot user-defined subclass. We'll now save our _bot layer should have any polygons from the SMD_S_bot layer that do not have opening. If we update our AND_NOT operation to put the arguments in the correct order, we can rerun our rule and test it. We'll update our rule and rerun the rule in the PCB editor. We'll rerun our
Click to anchor the transmission line element, and complete the connections by clicking on the pins. It looks messy. Let's do cleanup to arrange the elements. You implement the following rules. The length of the route from the driver to each branch must fall between 1000 to 6000 mils to the X net that is set at. Congratulations, you have completed Module 3.
This video will demonstrate creating a net group and setting the constraints available in the min-max propagation delay worksheet of it. So, we want to go from our driver to our resistor. From a resistor out to our T-points, so I need to add a couple of T-points. Now I'm going to just select on each node to make my connections. This should be the routing order that I wanted. I'm going from my driver to my... Let's start with our T-point to receivers. I'll go from the first T to pin U23. Everything passes because it's not routed. Big Explorer, and we can route these nets to see how they route. Route, PCB router, route automatic. Again, these are XNets, so those XNets are made up of a series of two nets. Lamp underscore series is from U20 to the resistor, and then the lamp nets are from the resistor to the main. So, we are actually good on this. I didn't really have to expand this, but just make sure you believe me. I'll do a right mouse button analog.
Subclass to subclass, check. And then we can just type in a description. This represents an opening in the actual cover layer material. So basically the cover layer more to the left here and a little bit more to the right. $15 mils. And rigid flex designs. We can also use this for standard PCB design. So let's go back to the constraint manager. Speed via structure must be an EXML file. For standard via structures, like on the browser button, let's use DP offset. Now notice that the assign return path net path, since the via structure that I'm using has a return path via in it, so I'm going to go
This video will demonstrate how to use the over one of the three ends and left mouse button click and hold and drag in the direction of the pointed end of the widget, or in the reverse direction. You can also select the center ball and select left click and drag to move the symbol manually in all the X, Y, and Z directions. Select the auto button to reset the symbol position. I am going to move the symbol manually in the Z-axis towards the north side and show you how different manually towards the Z direction south side so that I can select the face which I want on the top side. Select the top button from Controls and Mapping Info and select the face which you want in top side. Now you can see the selected face of the 3D model comes and sits on the top side. Let us use the auto option and make the symbol offset and rotation values manually and change the 3D symbol position and its orientation. I am going to show you an example of importing the 3D mapper files. We have already set our library paths where the 3D model. We will check how we will import the mechanical 3D model in the board file. Open the board file named 3D_PCB_demo.brd and open its 3D canvas. Click on the 3D mapper and bring it into focus. Select the mechanic.
This video will demonstrate the creation of a file. Now I probably need to add in some more, make sure that that's okay. I'll come back to my film. We created ground.art. Under the manufacturing class, I'm going to call it artwork. That's where I'm going to read the artwork files into. To read the artwork in, do a file, import.
Hello, this is Mark. Pin proximity and connections and connectivity for bundle generation. Point and the rake. As I grab that endpoint, you'll notice that the rake converts itself into what is called the extended rated bundle, and we've provided a specific direction that we want this particular bundle to be routed in, and we can say that we want specific nets to create a bundle, or if we wanted to add these to, again, a different.
That is the capacitor and resistor, and that component again did come from the schematic but can also be edited here in the layout. So let's take a look at the RFPCB edit change command, and I'm going to select this M-line component, and we'll display our GUI form and select the show diagram. Inserted RF components into the design entry HDL schematic. Into the RFPCB options tab here, and we make sure that we have the RFPCB import option turned on. Next thing we'll do is click OK to bring the changes in from the RF layout through the packager, and we'll update our schematic. So our schematic's been back annotated, and let's take a look at that parameter on the microstrip butterfly component. The line that we actually lengthened in the layout.
Press F2. Constraints are a very powerful gadget that stands out more in complex boards by pointing out mistakes and doing constant design rule checks, DRCs. This is not possible for SMD components. In this case, the via can just be created at the top layer, so we must add a connection on the top layer and add a through via. This generates a DRC due to the constraints that we created. VCC is a power net, so it is not allowed.
Hello, this is Henk van Houten from Cadance. Placed 4 times. Let me just go, which I've packaged as a reuse block. Please go back to the previous movie and you can double check your packaging settings if needed. Package your design in preserve mode. Check to see what you need to do with constraints. In this case, I will override the current constraints and I'll turn on the high speed and miniaturization option. Next, let me just import the netlist from my package design. Import logic. Import directory /packaged. Just click on import. And the last one, rotate and place this one. Next, you would normally complete your layout. So let me just look at the connectivity. You would do the placement, finish the placement or route.
Hello and welcome to your CAD list. Let me delete this newly created diff pair nets by right-clicking on the object and selecting delete. Then, confirm the deletion by clicking yes. To quickly value will be used. In this case, we have set it as 7 mils. When routing between pins and vias, such as in VGA areas, it is important to consider the neck gap and width rule. This rule should be applied to ensure that the traces fit correctly. In this case, we are setting the neck gap and width value the same as the primary value, with a tolerance of 0.1 mils. The minimum line space check is essential to prevent differential pair nets from coming too close together. Spacing, the tool will route the differential. This length should be added up for the entire differential pair route, as shown in the green edge. When the gather control is set to include, the uncoupled trace length from the pins to the gather point is added to the total uncoupled length. However, this video will demonstrate how you can create layer-based constraints, route the differential pair and select OK. You have added a new physical C-set in the work area. We will define the values for the 100 ohms impedance. The line width and neck lesser than the minimum neck gap minus tolerance value. Go to the PCB editor and select the route command. In the options window, set the start layer as top and the end layer as signal 3. Route the signals by adding vias and using the internal layer as alternate layers. Neck space, 4 mils, minus the tolerance, 0.02 mils. You won't get any shown. Choose the measure command, and if you query the air gaps at these places, you can see the air gap has been deviated by very minute values of less than 0.
Exist. The script will search for install scape directory in the path. Install scape is Cadance utility to download, install and configure releases. As install scape has already been installed, so type Y and press enter. Once the path is provided, the install scape GUI will invoke. Click local directory /media install. Click browse. Provide the path to source.
Any name you wish to. Feature 4 is selected for installation. You may manipulate the Features section to install the products.
The skill pro loop and it will use that new value for that naturals, a 7 or an 11 5 times. Another type of looping, once for each item in the list. Let's load and run our function, passing it a list of 5 dice rolls to see our for each loop run.
instance, we want a 20 mil gap between the bend area and a little bit more so we can see this DRC marker. You can see there's an I on the left-hand side, S on the right-hand shape boundary of another subclass. In this case, it's important to note that the cover layer is DRCs. So again, I can just use the shape edit application, which I'm in. I can select on one edge. I'll just drag that up a little bit. At this point, we've kind of looked at this in regards to how you use it with rigid flex designs. We can also use this for standard PCB design. So let's go back to the constraint manager. And there's the very top, we have a 1 inside 2 rule from the etch on the internal layer.
The user ID is created from the first 2 letters of the username. Select the markup tool in the comment card. Draw a rectangle to select an area or we can roll comments. You can also add a reply to a comment by typing in the text below a comment. You can also edit comments and markups in or Cadance. Select the markup from the design canvas, right-click and Comments panel. All the marks becomes invisible in the design canvas, however the comments remain visible in the Comments panel.
Hi, good day to all of you. Thanks for joining this webinar. This webinar is about design to deform technology, that how you can use design to deform technology over here, and then again you will be requesting the rule set from the customer. What kind of, I will just go into my constraint manager and I will show you like how the rules are getting added. You can, initially you had seen, right, there are no rules that were there, but right now like we have all those rules that has been added using the template. This uh, skill file in the cost portal, I had already loaded this skill. So when we want to create rules for not in stack up, okay, this not in stack up is for non-electrical layers. We want to create non-electrical layers. Say for example, I want to create a solder mask top or solder mask bottom layer. I can always go here. If I have film records, I can just directly select the film record.
Hello, I will just stay with mine. So here's list all the contributions done by this extension. As I said before, there is 2 ways to install an extension. If it's not available in the store, it is possible to use an, so for example, report, error highlight when a variable is not declared. So for example, this variable is declared here. We can just change the name. And as you can see, of each token by hovering over it. So for example, the report